All right, so far we've looked at all four of the CRUD capabilities that core data offers. So we've looked at creating, reading, updating, and destroying data using the context. And once we're happy with our changes, then we've committed those changes to our persistent container. So in this lesson, I want to talk about how you can query items using core data. So in order to do this, we're going to give our app a little bit more functionality. And the functionality that I want is having the search capability and adding that to our table view. So I want to be able to type in part of or completely a to-do list item. And I want our table view to update to show me all of the items that are related with that search term. So for example, I could have something like, buy milk and buy eggs, and I just want to search for buy to see what I need to get from the supermarket. So in order to do that, we're going to go into our trusted object library and we're going to search for a search bar. A little bit circular there, but the one that we want is the search bar, not the search bar and search display controller, because we're going to implement a really simple search bar. So I'm going to drag it onto our table view and I'm going to place it just below the navigation bar, so above the table view. So the next thing is to set our view controller as the delegate for the search bar, so that whenever there's any changes inside the search bar, like say when somebody hits the search button, then this is the class that's going to be informed, and we're going to deal with whatever they type in there inside our to-do list view controller. So I'm going to say UISearchBar delegate. Now, previously, every single time we've declared our view controller as a delegate of something, we also had to make an IP outlet for our search bar, and then inside view did load say something like searchbar.delegate equals self. So we're familiar with these two steps, adding the protocol in the class declaration and also setting the outlets delegate as self. Now, this is optional, so you can either do it in code or the alternative is you can simply hit Control, drag, and point to this little yellow icon, which represents the view controller. And if you let go, you see that there is a delegate for this outlet that you can set as the view controller, which remember the yellow icon represents. So make sure that you actually originate it from the search bar rather than from somewhere else, like say the table view, right? Because in this case, it's got a data source and a delegate, and you can see that they're already set up to be our view controller class. So it might even be easier going from the document outline and dragging it to the yellow icon and then hitting delegate. So the next step, if we go back into our to-do list view controller, is we need to add some delegate methods in order to make the UISearchBar delegate work, right? So what we can do is right at the bottom below load items, we can add the delegate method, and it's called searchbar. Usually, so for a lot of these methods, as long as you're aware they exist, you can pretty much guess what you should start typing in order to get this list of suggestions come up. And you can scroll through them looking at the information text as to what each one does until you find the one that you want, which is, in my case, search bar, search button clicked. So this tells the delegate that the search button was tapped, and that is the point where we want to reload our table view using the text that the user has inputted. So let's hit enter and insert that delegate function in there. Now, some of you might wonder, if we have so many of these delegates, say, we have UISearchBar delegate, then at a later stage we decide to add like a picker view, UI picker view delegate, then we decide to have one which is UI image picker controller delegate. If we have all of these stacking up because we need all of them in our app inside the same view controller, inside the same screen, then it's going to start getting pretty cramped up here. And you've also got different delegate methods that relate to each of these bits of functionality. For example, the search bar or the picker view or the image picker controller. And should they really all be crammed into the same class? I mean, it seems like it's going to get a little bit tight on space, right? Well, the alternative that we can use that you're going to see in a lot of projects that you download from GitHub or out there in the wild is this is the closing brace for our class, and everything inside is our to-do list view controller class. Now, if we go outside of the last curly brace and we create an extension, then we can extend the functionality of our to-do list view controller, and we can set it to be a UI search bar delegate. So the advantage of this is that we can split up the functionality of our view controller, and we can have specific parts that are responsible for specific things. So for example, this extension extends our base view controller and gives it the extra power or the extra functionality of being able to handle search bar methods. So the other advantage is that when you look up here, you can see that we've got the base class here and we've got our extension down here. And one of the downsides of MVC, or the model view controller pattern that Apple is such a big fan of, is that your C starts getting really, really big, and it basically becomes like tiny m, tiny v, and massive C. You often see this gigantic view controllers, especially when you look at Apple's example projects, and they just start getting really, really big. So it's really important that you modularize and try to split up the functionality as much as you can, not just for code organization, which is handy, but also so that when you come to debug it, you can narrow down on which section you need to look at instead of going through the entire page, right? So for example, if we had issues with our search bar, then we can navigate straight down to our extension that deals with all of the search bar functionality. And we can read only, maybe 10 lines rather than 100 lines of the page. So far, we've been using these mark comments in order to be able to look at our view controller and have this quick breakdown of what are the different sections and what are the methods in each section. But now we have this extension, and even though the extension unfortunately doesn't allow you to rename it, you can still put a mark above it so that you can see it as a separate section. So we'll call this search bar methods. And when we go into our file now, we can see our main class as well as our extension class, which is responsible for the search bar methods. So this is a very Swifty kind of pattern, and you're going to see this pretty much everywhere. And usually, as a rule of thumb, whenever I want to create a new protocol here, in the class declaration line, I tend to create a new extension and group the protocol methods together. Like we're going to do now. So inside our to-do list view controller extension, where we are extending the functionality with a search bar and some search bar methods, we've got this delegate method, which is going to be triggered once the user presses the search button on the search bar. So this is a good point for us to query our database and try to get back the results that the user is searching for. So as always, in order to read from the context, we always have to create a request, and we have to declare the request data type. So ns fetch request, and it's going to return an array of items. And we're going to set this to equal item dot fetch request. Now the next step is we have to specify what is going to be our filter, right? What is going to be our query? And we do that using something called an NS predicate. But before we do that, let's first have a look at what is the data that we get back when the user clicks on the search button in the search bar. So let's go ahead and just print out the search bar dot text. And let's go ahead and run our app. All right, so the first thing that we see is that we now have a search bar. Yay! That was pretty easy, right? And the first thing I'm going to do is I'm going to hit Command K, or go to Hardware and Keyboard and Toggle Software Keyboard. So Command K does exactly the same thing, and it basically pops up and pops down the keyboard on screen. And then I'm going to, for example, type save in order to pull up all the items that contain the word save in their title. And then I'm going to hit search. And this is the point where our search bar search button clicked, delegate method gets fired, and it runs everything that's inside. And so our print statement prints out what the search bar dot text at this point is, and it's the word that we entered, which is save. Okay, so that worked pretty nicely. It's always a good idea to check along the way to make sure that all your presumptions are right and all your setup, especially with these UI elements, have not gone awry. So we now have this request, and we need to modify it so that we tag on a query that specifies what we want to get back from the database. So in order to query objects using core data, we need to use something called an NS predicate. So we can say, for example, let predicate equals NS predicate, and we're going to initialize it using a format. So the format, as you can see from the placeholder, takes a string. And the string is a little bit scary because you're now typing in free text. And in our case, what we would do is we would say title. We're going to look at the title attribute of each of our items in our item array. And we're going to check that it contains a value. So this is the argument that we're going to substitute into this percentage @ sign. And I'm going to talk about why all of this looks so different from what we've been doing in Swift in just a moment, but let's just set it up first. And the argument is, of course, what we printed out in our print statement, which is the searchbar.text. And so when we hit the search button, then whatever we have entered inside the search bar at that time point is going to be passed in to this method into this part and replacing this percentage @ sign. So then our query becomes, for all the items in the item array, look for the ones where the title of the item contains this text. So this is pretty unfamiliar if you have only been working with Swift. This part might look quite familiar to you if you've ever used or looked at Objective-C code. And the reason is because NS predicate is basically a foundation class that specifies how data should be fetched or filtered. It's essentially a query language, which is like some sort of weird love child between the SQL where clause and a regex or regular expression. It's meant to be similar to natural language, like how you would speak in English, but there's a whole bunch of modifiers and logical conditions that you have access to that you can put inside this format string. So let's take a look at those. So a really good resource is actually on the Realm blog. And even though we're not using Realm yet, we're actually still using core data. When you query items inside Realm, they also use the same thing, which is NS predicate. So they've made this beautiful PDF that is essentially an NS predicate cheat sheet, which you can download from this link here, which I'll include in the resources for this lesson. But essentially, you can have a look at how the string is structured, right? So remember that the percentage @ sign substitutes any sort of argument that you want to pass in. And you can use most of your basic comparators, like left hand is equal to right hand, or left hand is greater than or equal to the right hand, as well as everything that we've been using so far. But it's also got some of these special words in all caps. For example, the word like between, right? The left hand expression is between or equal to the right hand expression. And you can compound your predicates together by using the and, or, and not. So you can say that the age is equal to 40 and the price is greater than 67. I don't know in which case you would have to look for something that has age over 40 and price over 67. Oh, maybe wines, I guess that works. I don't know why I was thinking about humans or pets. It's really bizarre. Anyways, so it's also got things like string comparison operators, which is what we use, which is the contains, because our title is a string. And we wanted to check to make sure that the titles of each of those items contains, i.e. it can partly contain the text that we're searching for, because we're not going to enter the exact word that we're looking for. If we're looking to try and pull up the items like buy milk and buy bread, then it's not very useful just searching for buy milk so that buy milk pops up, right? We want to look at all the things that contains the word buy. Now, if you wanted an exact match, then you might use something like matches, right? So that it exactly equals the right-hand side. So when you're dealing with strings, then these are some good ones to work with. For all the other data types, then usually you'd be using these basic comparators when you're working with numbers especially. So this is a brilliant cheat sheet. have a look at it, study it if you're going to be querying your database. And you can do a lot of really sophisticated stuff with it, and it's still relatively short and easily readable. And they've also got some tips, tricks, and examples which work with core data as well. It's basically how you search your databases using Realm or using core data. And another good article is this one on NS Predicate, written by Matt Thompson, who was one of the creators of Alamo Fire that we've been using so far. So a really good article on this if you want to read up more on it. And one of the things you need to remember about string comparisons using NS predicates, as you'll find in this article, is that string comparisons are by default case and diacritic sensitive. So case obviously means upper or lower case, and diacritic refers to these little marks above your letters. So for example, in French, you have the circonflexe and the grave accents, or in German, you have the umlauts. So these are the diacritics. And, you know, for us to implement search, do we really want it to be case sensitive and diacritic sensitive? Probably not. So you can modify that by just adding the square brackets and including C and D. So C stands for case and D stands for diacritic. And it makes it basically insensitive to these two things. So let's go back to our code and modify it with our new knowledge. So we can add it after the contains, and we're just going to add CD to it. So now we have structured our query, and we're going to add our query to our request. So we can say request.predicate equals predicate. All right, so now that we've created our predicate, which specifies how we want to query our database, the next thing that we can do is we can actually sort the data that we get back from the database in any order of our choice. So we can create a sort descriptor that is a NS sort descriptor, and we can say that we want to sort using the key that's the titles of each of the items, and we can sort it in alphabetical order by saying ascending equals true. So now we can add the sort descriptor to our request by saying request dot sort descriptors. So it's really important that you notice here that this property is actually plural, and that's because it expects an array of NS sort descriptors. But in our case, we actually just want to specify a single sort rule. So we're going to say sort descriptors equals an array of sort descriptors, but it only contains a single item, and that's perfectly valid code. So now all we have to do is to run our request and fetch the results, right? So if you have a look in our load items method, you can see that we've got a block of code that does exactly that. So we can copy and paste it over here so that we can try using our context to fetch these results from our persistent store that satisfy the rules that we've specified for our request, which is namely the title should contain whatever is in the search bar, and the results should come back with their titles assorted in ascending alphabetical order. So then we assign the results of that fetch to our item array, and we now need to reload our table view so that we retrigger the self_arrow_at_index_path method, and we update our table view with the current item array, which contains the results of the search. So now, as I always say, whenever you find yourself copy and pasting large chunks of code, then it's probably a good trigger for you to think about whether if you can refactor your code so that it's more succinct and you're not repeating yourself, but instead keeping our code dry. But before you refactor your code, you should always make sure that you test your assumptions and make sure that the current code works. So let's do that now. Let's run our app and see if it works. All right, so I've added a whole bunch of items that all contain the word save. So there's 4 items that contain a capitalized save. There's one lowercase save, and there's one save with a diacritic. So if we go into our search bar and search for the word save with a capital S, we're going to look inside all of these items and look for the ones that contain the word save, and our query is case and diacritic insensitive. So let's go ahead and hit search, which of course triggers the search bar search button clicked delegate method and executes all of this code. And what we get back is all of the items that contain the word save and its case and diacritic insensitive. So now that we've proven that our code works, then it's a good time to refactor our code. So one of the first things is that we probably don't need this constant, right? We can simply replace it with request.predicate. And we can delete this line. So 2 become 1. And we can replace this let's sort descriptor with request.sort descriptor. Now, before we can delete this line, we have to realize that sort descriptors expects an array of NS sort descriptors. So we have to add these square brackets around this line on the right-hand side in order to make it equivalent to this. And now we can finally delete that line. So now we've gone down from 4 to 2. And finally, as I said before, we've got this do catch block that's repeated inside our load items method. So I want to be able to call load item rather than having to write out all of this code again. So what I can do is I can comment out this code and I can modify this function to take a parameter that is the request. So this is going to be of data type ns fetch request, and it's going to return an array of items. So now, instead of repeating this do catch block, I can simply say load items, and the request that I want to make is this modified request, which contains the query and the sort descriptors. So I can say load items with request, and the request is this one. So the only problem here is that load items request doesn't really make a lot of sense in English, right? And what you notice with Swift is that it's really pro natural language. So you want to have your method calls sound almost like they make sense in English. So having request is kind of confusing and doesn't make a lot of sense. So we can modify this parameter to also have an external parameter. So this is the external parameter and this is the internal parameter. So the internal parameter is going to be used inside this block of code. And the external one is the one that we're going to use when we call the function. So now that reads a little bit better. Load items with request, right? Now what's happening is we're creating a new request. Then we modify it with our query and our sort descriptor. And then we pass that request into our load items function over here as an NSFetch request. And then we perform that request by saying context.fetch. So we can now delete this do catch block, and we can also delete tableview.reloadData because it's already inside load items. And we now have a shorter and much sweeter block of code. Now, because we're passing in the request, and then we're creating a new constant called request, it's a little bit confusing which one is used here. And in fact, we don't really need this line if we're going to pass in the request. We don't need to reinitialize a new request, right? Now, there's just one problem, and Xcode is actually notifying you of it using this little error here. And it's saying, right at the beginning, when we perform view.did_load, we also call load items. And this is where we want to load up all of the to-do list items from our persistent container. And at this point, we're not really interested in querying it or sorting it. We just want every single to-do list item so that we can show it in our table view. But now this load items method actually expects a parameter. So what can we do? Well, we could maybe copy this line of code and paste it up here. So we can say let request equals just fetch all of the items from the persistent store, and we can now pass it in as a parameter, say load items with request. But this is not really ideal, and it's not all that succinct either. So we can actually shorten this code even more by providing our parameter with a default value. So we can say that the request is of type NSFetchRequest, which should fetch an array of items. That's the data type. And if, when we call this function and we don't provide a value for the request, then we can have a default value that's simply item.fetchRequest. So now we can delete this line of code, and we can be safe in knowing that when we call load items with request and we provide an argument then that's the one that we're going to fetch from our context. But if we call our load items without a NSFetchRequest item, then we can simply use the default value, which is item.fetchRequest. And what this allows us to do is up here, when we call load items, we can simply call it as we did before without giving it any parameters. And we can also delete this line of code. So this method is a little bit complex because we have an external and an internal parameter, but also it has a default value in cases where we call load items without giving it any parameters. So it's a good idea to have a play around, maybe in playgrounds, at creating methods that have internal and external parameters, just to see how it works, and also to create methods that have default values, so you can see how you can call them and how you can create them. Now, there's just one problem with our search bar, and it's the fact that we can't actually get back to our original table view. What do we do once we're satisfied with searching for the word save, and we actually want to go back to seeing all of the to-do list items? It doesn't help if we try and click the cross and delete all the search. We can't get back, right? And that's because we haven't written any code to do that yet. So that's what we're going to do in the next lesson. We're going to address that bug and we're going to fix our table view so that we can return to our original state. So for all of that and more, I'll see you on the next lesson.